Let us talk about the optimal choice and the tangency rule. So is this tangency rule a sufficient condition also? Is the tangency rule just a necessary condition? Let's look at this. And will this tangency rule always hold? Well, we know this, that given their budgets, given the budgets of the consumers are always going to choose the most preferred affordable bundle, right? So naturally, I mean, they would want to consume more and more, but they are constrained by their budgets. So, and what about this point? Let's say this is my budget line, and I do not have to worry much about the bundles which are inside the budget. Why? Because in case if I look at this particular, let's say this particular point, then the indifference curve passing through this particular point is like this, right? But of course, if this point is affordable, even this point is affordable. And the indifference curve passing through this point is this. But why to even worry about this? Because if I consume on the budget, then what will happen is that I will be at a higher indifference curve as compared to when I am inside the budget. You with me? So because of that reason, you can actually not worry about the bundles which are inside the budget. So you can just focus your attention on which are on the budget. So the bundles which are on the budget line, these bundles beta, which are on the budget line. So of course, beyond the budget line are completely out of the picture. They're not affordable. You don't even have to worry about them. So one thing which we have seen is, now you just look at the bundles which are on the budget line. For example, this bundle, let us say. So the indifference curve passing through this bundle is U0. Is this giving you the higher utility? No. You can go further. Just move little upwards. This point is also on the budget line, and the indifference curve passing through this point is this. But of course, U1 is better than U0. But can you do even better than this? Of course you can. You move ahead and you will move on to this point. This is the highest utility which you can have, because in case if you move, let's say, to this particular point, then the indifference curve which is going to pass through this point will be lower than U2. And hence is giving you the lower utility. And what is unique about this particular point? Let's say this point is x1 star, x2 star. This point which is giving you the highest utility. This point is x1 star, x2 star. This is actually giving you the point of tangency of the indifference curve in the budget line. So you are getting the highest utility at the bundle where indifference curve is tangent to the budget line, right? Indifference curve is tangent to the budget line. So at any other bundle, if you look at it, whether here or here or here or here, wherever, indifference curve is crossing the budget line and you are at a lower utility as compared to this point, let's say point E, where you're consuming x1 star and x2 star, where indifference curve is just tangent to the budget line, right? One thing is that. So, and of course, the bundles above than that are completely unaffordable. You don't have to worry about them. So this is, one is the tangency condition. This is what the tangency condition is. So at the optimal point, indifference curve is tangent to the budget line. So please write. At the optimal point, indifference curve is tangent to the budget line, right? Because in case if that is not the case, then indifference curve is going to cross the budget line, and that will not give you the highest utility. One thing is that. Achha, then the condition which arises is that will this tangency always hold? So the question is that will this tangency always hold? No, not necessary. Not necessary. So you might have one case of kinky preferences. Kinky preferences. And one of the example of kinky preferences you've already done. What is that? That is your min function. It's also like a kinky preference, perfect complements. So something like this. And what is it that I have told you about the kinky preference? That is, you will draw the kink line first. So I'm just assuming min of xy. And we have also seen that. So this was my kink line, x1 equals to x2. This is my budget. And then I'm asking myself, what is the highest indifference curve I can draw? Is this the highest one? No. Is this the highest one? No. This one is the highest one. So it's not tangent, right? So there's no unique tangent at this kink point. There's no unique tangent at the kink point. So the mathematical definition of the tangent would require that there should be a unique tangent at every point. So that's not the point here. So one thing is that in such a situation, this tangency condition is not holding. We have done this, beta. We have done this, u equals to min of xy. We have already done. So if you have not seen this, please have a look at the another video on which we have talked about the perfect complements. So in this condition, tangency is not holding. Tangency doesn't hold. There's another condition also, for example, corner solution. So this is what x1 is, this is what x2 is, and this is what my budget line is. But supposedly if my indifference curve, they look like this. They look like this. And then I'm asking myself that given this black budget line, what is the highest indifference curve I can draw? Is this the highest one? No. I can go still further. I can go still further. So this point. Here the slope of indifference curve and the slope of the budget line are not same. Here they are. At point E, the slope of the indifference curve and the slope of the budget line are same. But here it is not. So this is the case of the boundary solution. Case 2. Corner solution. Or you may also say boundary solution, right? So boundary solution, I'm so sorry. Boundary solution is where one of the good is not being consumed. So where consumption of one of the good is 0. So only x1 is consumed. Right? Consumption of x2 is 0. So corner solution or boundary solution would be where consumption of one of the good is not 0, right? So optimal here, and of course this particular point is optimal. So optimal is occurring at the point where consumption of one of the good is 0. So here, this is the optimal beta. So tangency is again not holding even in this particular case, right? Strictly speaking. So tangency is not holding. So slope of the indifference curve and the slope of the budget line are not same, although indifference curve is not crossing, definitely, right? The indifference curve is still not crossing. So you may just write one point, that is the slope of indifference curve and slope of budget line are not same at optimal, although indifference curve does not cross the budget line, right? Does not cross the budget line. So these are the two cases. I mean, so just thinking about it, I mean, I'll also make a video on corner solutions. So what can all be the cases for corner solutions? And if you remember, we have done that. That is, we have done those cases where there can be corner solutions. For example, in perfect substitutes, there's a situation in which, yes, you can consume only one of them. We've also done quasi-linear preferences. There can be a situation in which you're consuming only X. So that is also a corner solution. Other corner solutions can also arise in case of concave preferences. We still have to do that. Okay, beta. So now the question arises, can you just forget about the kinky preferences and corner solutions for the time being, and you just worry about the interior solution? You just worry about the interior solution. Then can you say that yes, tangency condition is a necessary condition? Yes. So if you just rule out kinky preferences and the corner solutions are where one of the good is not being consumed. In interior solution, you are consuming some of both the goods. So you're consuming some amount of x1 and you're consuming some amount of x2. So if you focus only on interior solutions, let's say, and then yes, the tangency is, and if you are able to find out a tangent point, then that is going to be an optimum. Tangent point between the indifference curve and the budget line, that's going to be an optimum. So the idea is that if the optimal choice is going to involve some amount of both x1 and x2, then yes, the tangency is going to necessarily imply yes, this is going to be an optimum, right? So please write this: if the optimal choice involves consuming some of both goods, right? Some of both goods means that it is necessarily an interior optimum, so that it is an interior solution then necessarily IC will be tangent to the budget line. IC will be tangent to the budget line, right, beta? So because in case if it is not, then your indifference curve is going to cross the budget line, only at the tangent point indifference curve is not going to cross the budget line. And if that tangent point is also the interior solution where you're consuming some of both the goods, then yes, the tangency is what the necessary condition is. But the question is that tangency is not a sufficient condition. It is only a necessary condition, and that too also in certain restrictions. So the question which arises next is that, is tangency a sufficient condition also? Is tangency condition condition a sufficient condition also? Not necessary, right? Okay, so you have, is this a sufficient condition also? So we look at an example like this. So what you're trying to say is that, so if you're able to find out a point which is tangent, right? So can you just say that yes, this is actually going to be an optima, right? So you're sure of having an optimal choice. So let's say you have this as the budget line. Right? And this is one indifference curve. This is another indifference curve. This is another indifference curve. So this is one tangency, this is another tangency, this is another tangency. So naturally these 2 points, this point and this point, they are the optimal, but not this point. It is not optimal. Although it is a tangent point, although it satisfies tangency, or it is a tangent point, right? So you can't say that if you find a bundle where indifference curve is tangent to the budget line, you're not sure that you have got the optimal. So this particular point which we're talking about, this is, although it is, your indifference curve is tangent to the budget line, but this is not an optimal because you can go still further. So this is not a sufficient condition. Tangency condition is only a necessary condition. It is not a sufficient condition, right? And that also is a necessary condition, particularly only in interior solution case. So can you have a case where tangency condition is both necessary as well as sufficient? Yes, in case of the strictly convex preferences. Can we have a case? Where tangency condition is both necessary as well as sufficient. Yes, you can have in case of your strictly convex preferences. So if you look at this point, this diagram out here, so you have an interior solution and you have the strictly convex preferences. So in case of strictly convex preferences, yes, the tangency condition has to satisfy the tangency condition must be an optimal point. One thing is that. So, but in case of strictly convex preferences, I mean, they can only be one optimum. So although in case of convex preferences, as in case of the perfect substitutes, you can have more than one optimal also. But in case of strictly convex preferences, that tangent point which is defining an optimum, that will also be unique. So you may just write 1 or 2 lines out here. So yes, in case of convex preferences, or convex indifference curves, any point that satisfies the tangency condition must be optimal. You've seen the first diagram. So those are strictly convex preferences also. So one more restriction is, so there can be more than one optimal also in case of convex preferences, but for a strictly convex preferences, there will be only one optimal at the tangency point. So if ICs are strictly convex, then there will be only one optimal choice. On each budget line. There will be only one optimal choice on each budget line. So only in case of strictly convex preferences, you can have the tangency condition is both the necessary and the sufficient condition. Otherwise, tangency is just the necessary condition, is not necessarily a sufficient condition, right? Okay, thank you, beta.